Okay, folks, so before we go on actually to our shell scripts, there is one more thing that we need to do, right? Which is that we need to write some headers to our data file. We could do this manually after creating everything, but that's still kind of a pain. You have to be poking around for things quite a lot. It's always nice to do these things in a holistic way. The problem is that, or the issue that we face here is that unlike our first example when we were working with an existing CSV and we could use some of the CSV recipes to pull the header row out of it, we don't have an existing header row in this case. So instead what we need to do is we need to find a way to, we basically just need to tell this, look, from the first file that you load, basically we need to grab the header row, but we need to grab it only once. Again, we could grab it from each file or each row, but that would be pretty messy. So instead what we're going to do is we're going to say, look, because we're processing a lot of files, all of those files have a header row, we only want one header row for all of those files. We're going to do something up here. This is a little bit different. This is going to be the first time that we create a Boolean of our own. And basically, we're just going to say, look, does this file still need a header row, right? In other words, has the header row yet been written? And if we recall what we're doing here, and of course you will all be commenting heavily, so I'm sure you will recall. If we recall what we're doing here, we're saying, okay, go through every file, and then for each file, I'm going to open the file and I'm going to load the data. Now, I only need to pull the headers once, even though I might have 2 or 3 or 10 files, right? But where do I get those headers? Well, the headers are going to be the names of the attributes in this case, right? So I have the attributes, I'm looking at the attributes down here, but if I try to create a row with the, if I try to create a header row in here, I'm going to end up writing a header row every single time. And I don't want to do that. So instead what I'm going to do is I'm actually going to have to say, look, I want to, if I still need a header, right, as in header row equals true, needs header equals true, then, so if needs header equals true, remember we use our equals to compare, right, is needs header, does it have a value of true? Then I'm going to say, all right, look, I'm going to create a new header row, right, which again is just going to be an empty list there. I'm going to go ahead and append to header row my first element, right? Because if you remember that the first thing I'm doing in each case here is appending the execution time. So my first column is actually the execution time of the file. So I'm going to say, okay, I want you to append, and I'm going to make up a name for it. I'm going to say file date, right? That was the date the file was loaded. And then I'm going to say, and it's going to be exactly the same thing as here, except rather than looking for the value, I'm just going to append the attribute itself. So I'm going to say, okay, for attribute in station, I want you to add the name of the attribute to my header row list. Okay? When I'm done with that, I'm going to go ahead and write that row, that header row, to my output file, right? Okay, and now, very important here, if this has been done once, right, I don't want to do it again. Otherwise, every other row that I get in my data is going to be just like the names of the column headers. So it's very important here that what I do is I now say, by the way, I no longer need a header. So I set needs header to false. Because needs header was established before this for loop, right? The only place that it gets changed is in this case, right? So what happens is I've created this variable, I've said the value is true, right? I put the value true in the box labeled needs header. I come through this in the very first time, okay, I get my first file name, I'm going to load the data from it, I'm going to go through each station, and I hit this condition, right? And I say, look, does this equal true? Well, obviously the first time that's going to be the case, it's going to equal true. So I do all of this, and then I say, by the way, this thing, make it false, right? Now I want you to replace what's in the box labeled needs header with the value false. And then I go about my business processing my first row of data from my first file. All is well in the world. What's important to remember is that both when it comes back up here, so that once I've done that first file, when I come back up here, it's going to say, okay, get the next file name. But every time it comes down here, the value of needs header will now be false. So it's only going to execute this one time. So I can test this again. I'm going to say run my script. Doesn't take very long because I'm not parsing that much data. And I'm going to go ahead and open this in Microsoft Excel, and you can see that I have successfully added the file the attribute headers. Now what's interesting is that this also kind of demonstrates to us all of the values that are possible in our city bike station feed, but don't actually have values in them, right? So city, altitude, street address, postal code, which is kind of a bummer. That would probably be useful to us. Is it a test station? So this is sort of a street address, right? It's actually just the same as the station name. It says does it have a landmark? That would be kind of interesting to facet on, right? And then the available bikes and the ID and the location, right? So location also doesn't have value. So that's how we can go about adding header rows when we don't have an original CSV to work with. You could also do this manually, right? I could just say, by the way, my headers, equals, right? And then I could just manually enter a list as we demonstrated in class, right? That's always an option, but this is just a way to get it out of the data that I'm already processing. So now that we've solved that, the question is, how do we streamline the process of having to go to the website and copy the data off of this URL and then save it in a text edit file and do all this stuff, right? Not only is it tedious, but it's hard to do with good precision, right? Because often we want to be doing something exactly every 10 minutes or exactly every hour or exactly every day at the same time. And that, would be kind of a damper on things if you had to make sure that at exactly noon every day you were there to download this file. So what we're going to look at is a shell script, a basic example of a shell script. Now this is all, I'm just going to sort of give this to you, but I hope that, but I think that you'll hopefully find it useful, and it's certainly something that you can explore on your own beyond this class if you want to. But if you're doing kind of some basic data collection, you can always run this kind of thing if just kind of in the background, which is nice. So I'm going to say new file. Oh no, I'm not going to say new file because that's going to be really annoying. So I'm going to say new from template, but I'm going to lie and I'm going to pretend that I'm going to do a Python file, but I'm actually not going to make it a Python file. So I'm going to save this. I think I'm going to save it. I'm going to save as. Okay. And so remember that the file extension is just something that the computer uses to guess which program to run it with. So I'm going to call this JSON download.sh. .sh is the the file extension for shell scripts. Now, we're going to use a different kind of for loop in this, and what we're going to do is we're going to do something a certain number of times. There are other ways to measure this, but I'm going to say I want to do something 5 times. That's going to be how I specify. I want to download the file 5 times over the course of 5 minutes, or maybe over a minute because we're not going to wait 5 minutes in the videos. So here we go. I'm going to start by saying for. So you see that the for syntax, right, the for loop concept is really universal. Okay, shell scripts have been around since the very first computing systems. And in this case, what I'm going to do is I have to use something we're calling it an iterator, right? It's something that it's basically the same thing as our for in loop, but we're much more specific in this case. So I'm going to say from I equals 1. So I'm going to say start at the number 1 until up till 6, right? Or I could say equal then 6, right? So I'm going to get 1, 2, 3, 4, 5 because I'm looking for things that are less than 6. And then in this case, I specify very particularly, I want you to add 1 to the value that I have. So I is a box, again, it's just a variable. So create a box, label it I, put the value 1 in it. We're going to increment the value just the same way. We're actually moving through a list in exactly the same way that we do in Python. It's just written a little bit differently, a little bit more explicitly. And then I say do. And again, this is just how it works with shell scripts. Okay, and then the command that I'm going to use is called curl. We write it in all lowercase, but it stands for copy URL. So that's what's going to actually grab all of the stuff from the URL that we pass to this script. So now we need to pass it the location where we want it to save our files to, right? So the first thing that I'm going to do is put in the name of the folder, which I think is JSON downloads, maybe. Yep, JSON downloads. Then I'm going to give it a file name. So I'm going to say, okay, I want each of these file names to start with city bike, data. And now we have this problem of we need somehow to make these file names unique, because if I don't make them unique, if I just said citybikeData.json, every time it executes, it's going to just overwrite my existing data file. So what I can do is I can actually use the fact that that I is a variable here. Now I use $sign inside the for loop. Again, this is only in shell scripts, but basically what I'm saying is, look, take the value that is in the variable I, which the first time will be 1, the second time will be 2, 3, 4, 5, right? And make that part of the file name that you write. Okay, so I've told it now what the name, where the file should go. Then I'm going to tell it where to get the file from. That's just going to be this URL right here, right? And importantly, I also have to tell it that, by the way, I want you to I should have put curl -o, okay? And the -o stands for output. So the way this reads is curl to the output file called JSON download city bike beta blah 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 JSON from this URL, okay? And then what I'm going to do is I'm going to say sleep. This is the syntax, right? The command, the recipe is called sleep. You're going to sleep, and in this case, I'm going to say sleep for 10. The default is in seconds, so it's going to say sleep for 10 seconds and then do it again. So every 10 seconds, 5 times, this script is going to download a copy of the data, give it a new file name, and save it in my folder. Now, obviously, it's not going to change much in those 10 seconds. You would want to put in a longer wait, but for us just to see that this is working, we're just going to put in sleep 10. And then finally, we do something that seems very, I don't know, sensible to me. We type done. That's how we tell it that it's finished, that the script is finished. And actually, I left something out here, which is that I need to have that semicolon. So again, I know this is different than what we've been looking at. Shell scripting is unusual, but because it's useful, I just want you all to have this introduction. Okay, so how do we run this? I can actually run this right from my same terminal. So if I do an ls, I see that I now have my JSON download.sh file. And if I run sh, so again, sh is the name of the language, the interpreter to use. When we use Python, we type Python. When we use shell scripts, we type sh. And then I'm going to say JSON download.sh. And if things are working well, what we can see is exactly what it's doing. So it's saying percent total, percent received, transferred, average download speed, or average download speed, average upload speed, et cetera, et cetera. So it's basically giving us the information about these files that it's creating every single time. So you see it actually isn't the same size every time, which is sort of interesting. And if we wait our requisite 50 seconds, we should get all of these. But I can check, and you see that in my folder here are appearing these new files. And there's the 5th one. So hopefully this gives you a sense of some of what can be done with a combination of shell scripts and Python for parsing both large data sets and multiple data files into one useful spot. And we'll obviously be going over this in class, and I look forward to seeing you all then.